Hello everyone, I hope you're doing well. In this MTH 141 video, we're taking a look at question 1.2.3 from the textbook A First Course in Linear Algebra by Kuttler. You can find my notes for this course on my website, tutor.ca, where you can also find information about my private tutoring services. Okay, so let's take a look here at this question. Do the three lines x plus 2y equals 1, 2x minus y equals 1, and 4x plus 3y equals 3 have a common point of intersection? If so, find the point, and if not, tell why they don't have such a common point of intersection. Okay, so essentially we have a system of three equations, right? Each one is in two variables, so each one's a line. I'm going to write them as a system here. So that's the little bracket notation I use to draw a system. So the first line was x plus 2y equals 1. 2x minus y equals 1 is our second equation, and 4x plus 3y equals 3 is our final equation. Okay, so we're trying to see, does this system have a common point of intersection? Is there a solution to this system? Those two things mean the same thing. Three lines having a common point of intersection and a solution to the system of those three lines. The exact same idea, just phrased in different ways. Right? So we can figure that out by doing row operations on this system to get it in a form where we can solve for x and y, right? We're looking for some point x, y, right? Every point on the xy plane has two values, x, y. We're looking for a point like 2, 5. That's just an example. You know, does 2, 5 satisfy this? When I put 2 in for x and 5 in for y, are all three equations true at the same time? Probably not, because I guessed that. So let's try to actually solve for the solution here. So one way to solve this is to think of it like this. If these three lines actually have a common point of intersection, that means that if I were to draw the first two lines, only the first two, that's these two right here, they must have a common point of intersection. And the third line, which I'll draw in yellow, the third line must go through that point. So if these three lines truly have a common point of intersection, then that must be true. So it's a little bit of a simpler way of doing this than having to solve a system of three equations. That's not too hard to do once we're in the next section. It's just that when we do it with elementary operations, it's a little tricky. Elementary operations are not the easiest things to work with. That's the whole point of our next section, which is Gaussian Elimination, which is a systematic way of doing this. We turn the elementary operations into elementary row operations, and they're exactly the same thing, but it's in a new perspective that makes everything a lot easier. So for now, when we're just working with elementary operations, and let me just quickly put on the screen what the elementary operations are. So they are right here. So the elementary operations are interchange the order in which the equations are listed, multiply any equation by a non-zero number, and replace any equation with itself added to a multiple of another equation. So when we're just using the elementary operations, we want to try to figure out a better way of doing this. And so if you think about it, right, do the first two lines have a point of intersection? If they do, then the third line has to also go through that point. If that third line also goes through that point, then that's the solution to the whole system of three equations. If the first two lines don't have a solution, as in they're either parallel, no, they must, that's the only option, they must be parallel, right? If they're parallel, then we know the whole system has no solutions, right? So if this happens, then we know there's a unique solution, right? There is a common point of intersection. If this happens, as in, I'll draw it in black because that's why I drew. The first two lines are the black lines, right? If these two are parallel, then there's no solutions. And then the final option that could happen is that the first two lines intersect. First two lines intersect at this green point, but the third line does not pass through that point, in which case there would also be no solutions. So we're looking for the first two lines to intersect and the third line to also pass through that point. And that would be the solution to our system. So I'm going to simplify this a little bit, and I'm going to turn this into a smaller system. Again, I'm doing this because when we're working with elementary operations, we kind of want to, think about this a little harder in order to not have to do as many elementary operations to solve this. Right, so x plus 2y equals 1 is our first equation. 2x minus y equals 1 is our second equation. So now we want to use our elementary operations to find the solution to this system. Okay, so generally the first step in doing this is you have to decide, okay, well, I want to eliminate a variable in one of the equations. Typically, it's the second equation, right? I want to eliminate x from the second equation, right? What this does is if I can eliminate x here, then I'd have one equation, one unknown on the bottom. Just solve for y. So to do that, the first step is usually to make the coefficients in front of the variable you want to remove equal to 1. So here it's 1. Here it's 2, though, right? So what I want to do is I want to take row 2 and multiply it by a half. That's my type 2 elementary operation, like that. And if I do that, right, if I multiply it by a half, then the new system is, first equation stays unchanged, x plus 2y equals 1. Second equation is just multiply by a half. 2 times a half is 1, so it's x. Negative 1 times a half is minus a half. And 1 times a half is a half. Okay. So now, in order to get x out, to eliminate x from this bottom equation, I'm going to do row 2. Right? So first of all, let's actually read our type 3 elementary operation. Replace any equation with itself added to a multiple of another equation. So I'm going to take row 2 and turn it into itself added to a multiple of another equation. Equation and row here are kind of used interchangeably. And so I'm taking row 2, replacing it with itself, plus negative 1 times row 1. What this does is this is essentially the same as saying row 2 minus row 1. Really, it's the same thing. And what it's going to end up happening is I'm going to have an x minus x happening there on the bottom, and it's going to be negative 1/2 y minus 2y, and 1/2 minus 1. Let's actually write that out so you can see what I'm talking about. So first equation stays unchanged. X plus 2y equals 1. Second equation, x minus x, that's 0x. Negative 1/2 y minus 2y, right? So that's going to be, I'll write that out here. So it's going to be negative 1/2 y minus 2y, right? Equals 1/2 minus 1, it's negative a half. Now let's just figure out what's negative 1/2 minus 2y. Well, 2 is the same thing as 4 over 2. So negative 1/2 minus 4/2 is negative 5/2. Or rewrite that as negative 5/2 y. Okay, there we go. So as you can see, what happened now by that operation is that we got a 0x here. That's just nothing. 0 times any real number is 0. So we can just cancel out that term. And now all we have left is this equation, one equation, one unknown, just like 1 on the bottom here. We can just solve for y. Y is going to end up being, let me think about this for a second, it's going to be 1/5. Y is 1/5. Yeah. Good. Okay. Makes sense. Yeah, y is 1/5. So since y is 1/5, we can substitute that into our first equation here. X plus 2y equals 1, which is going to turn into x plus 2 times the 5th equals 1, which is that x equals 1 minus 2/5. Well, what's 1 minus 2/5? 1 is 5/5. So 5/5 minus 2/5 is 3/5. And finally, we get our answer, which is that x, y is equal to 3/5, 1/5. And that's the solution to the first 2 lines. Now, to see if that's a solution to our whole system, we need to see if the third line passes through that point. Let's look at our third line. So third, I'm going to say row 3, right? It's row 3. And row 3 was 4x plus 3y equals 3. If this line passes through this point, when I substitute this point into the equation, I should get an equation that's true. Left-hand side should equal right-hand side. I can't talk. Left-hand side should equal right-hand side. So let's substitute that in. It's going to be 4 times 3/5 plus 3 times 1/5 should equal 3, right? It's going to be 12/5 plus 3/5 should equal 3. 15/5 should equal 3. 3 equals 3. Good. So this is true, this is true, this is true, this is true. And so this is true up here. And what that tells us is that this point is on this line. And since that line passes through this point, which is a solution to the original two lines, this is the situation we have. The two black lines had a solution. The third line passes through that point. That tells us that we have a unique solution to the system of three equations. And so yes, the question is, does it have a common point of intersection? Yes, it does. Find that point if it does, and that point would be 3 over 5, 1 over 5. Okay, that's everything for this question. I hope it was helpful. Thank you so much for watching, and have a nice day.